Welcome back, ladies and gentlemen. Please, let's take one of two questions on using the graphical method because I realize that is something interesting that each and every one of us needs more of the workings on so that when we come across such questions, you'll be able to do them with or without the graph. If you have to use elimination substitution, you'll be able to do them. After solving two questions on the graphical method, I would want us to look at how we are going to apply the linear simultaneous equations on some of the word problems that we face day in day out, and then see how best we can maneuver our ways around it. Thank you. Yes, so we are to solve y is equal to 5 minus x and y is equal to 2x minus 1 using the graphical method. So like I said, first of all, we need to write the two of them in their linear forms or the linear equation form, which is, so here we are going to send the y to this side so that it becomes 0. So 0 is equal to 5 minus x minus y. We can arrange it better by having minus x minus y plus 5 is equal to 0. You can divide 2 by negative so that we get x plus y minus 5 is equal to 0. We name this as equation 1. Second one, 2x minus 1 minus y is equal to 0, equation 2. So from equation 1, x-intercept, that is where y is equal to 0. For x-intercept, y is equal to 0. So I have x plus 0 minus 5 is equal to 0. X is equal to 5. So I have 5, 0 as my first point. And then for y-intercept, x is equal to 0. In that case too, I'm going to have 0 plus y minus 5 is equal to 0. We have y is equal to 5. So we have 0, 5, second point. Okay. Then for the equation 2, for x-intercept, y is equal to 0. So I have 2x minus 1 minus 0 is equal to 0. 2x is equal to 1. X is equal to 1 over 2, which is the same as 0 0.5. So I have 0 0.5, 0. And then for y-intercept, x is equal to 0. X is equal to 0. 2 times 0 minus 1 minus y. Minus 1 is equal to y. So therefore, y is equal to minus 1. So I have 0 minus 1. Okay. Now I can put this on the graph now. The highest x value is 5. The highest y value is 5. I don't know if this had to be good enough to fit. So I have this. I'm just improvising because I don't have the graph. Okay. So 0 here. 1, 2, 3, 4, and then 5. Probably 6. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. 1, 2, 3, 4, 5, 6. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay. So when I check clearly, I can see that the first coordinate is 5 against 0. So 5 on the x-axis and then 0 on the y-axis. I locate 5 on the x-axis. I don't move any further upwards. I locate the second one, 0 on the x-axis, 5 on the y-axis. So here. Now I can draw a line to cut through this like this. And then this is the equation which is given by x plus y minus 5 is equal to 0. Then I take the second one. The second one too is given by 0.5 and then 0. So half, which would be somewhere here, 0.5 against 0. So here. And then also I have 0 against minus 1. So 0 for the x and minus 1 for the y. So I trace this nicely through this bracket. Okay. So if I'm to trace it properly, I can see my x giving me 3 and my y giving 2. That is if I do it well. So I have x is equal to 3 and then y is equal to 2. So this is how we simply use the graphical method to work with something like this. So please, you can use the other methods to confirm. Let's do that so that we confirm if we are right or we are wrong. Okay, so I can clean this part of the board now. Okay, so over here too, it will be very easy if we so this is equation 1. Okay, let's use the original equations which were given by this, and then now since here is y here, so I will just equate the two equations. So 5 minus 2x is equal to 2x minus 1. Sorry, 5 minus x. Oh. So I group like them to have 5 plus 1 is equal to 2x plus x. 3x is equal to 6. X is equal to 3. So therefore x is equal to 3. Now I put x is equal to 3 into either equation 1 or equation 2. So let's call this equation 1. Y is equal to 5 minus 3. Y is equal to 2. So I can see clearly that x is equal to 3 and then y is equal to 2. If I use the graphical method, I get it. If I use the substitution or the elimination method too, I get it. So you see that it's not something that is difficult. Thank you. And then I'll see you in the next example that I'm going to solve. Bye bye.